You're about to witness a takeoff so powerful, the ground literally shakes. This is the CH-53K King Stallion, America's most extreme heavy lift helicopter. But what if I told you that its most terrifying capability is something you never see in the takeoff footage? Something hidden beneath the noise, the dust, and the rotor blades. Stay with me, because in the next few minutes, you're going to learn why the CH-53K isn't just big, it's a flying power revelation. The CH-53K King Stallion was engineered for one mission to lift what no other helicopter can. But its takeoff behavior, violent, raw, yet impossibly controlled, hides a deeper truth about its power system. The CH-53K can lift a 16-ton payload externally, in high heat and high altitude conditions where most helicopters fail. But how does it create enough raw force to defy conditions that normally cripple aircraft? You'll see in a moment. To understand the King Stallion's takeoff power, you need the context. The CH-53 platform has existed for decades. The CH-53E was already a monster. But the K model, it isn't just an upgrade. It's a new species of rotorcraft. 3 engines, 7,500 horsepower each. A composite rotor system that produces insane lift. A digital flight control system that manages all of this chaos with absolute precision. The CH-53K uses fly-by-wire controls, the first heavy-lift helicopter to do so. But fly-by-wire isn't the secret. The secret is how the system reacts during takeoff, something you only understand if you see it from the inside. Now here's where the story turns dramatic. When the King Stallion was being tested, engineers kept running into one brutal problem. The engines could deliver insane torque, but the airframe needed to survive it. The gearbox needed to transfer it. The rotors needed to keep their shape under massive aerodynamic load. The CH-53K has the most powerful gearbox ever installed on a helicopter. It transfers 22,000 horsepower from the engines to the rotors. But the engineers discovered something unexpected during testing, something that changed the entire takeoff sequence forever. During early takeoff trials, sensors began reporting unusual behavior. The helicopter was producing asymmetric lift during high-power climbs, one wrong movement, and the aircraft could roll. The solution wasn't to reduce power. It was to create a system that controlled it with unimaginable precision. A system so advanced, it adjusts blade pitch thousands of times per second. Here's the truth no one tells you. When the CH-53K takes off, you're not seeing the real power. You're seeing the controlled version of it, the vibration, the roar, the aggressive nose uplift. That's only a portion of what the engines can truly deliver. During takeoff, the helicopter uses only 60 to 70% of its full torque capacity. The rest, it's reserve power. For emergencies, for battlefield conditions, for high-altitude insertions, for extreme heat missions. The King Stallion is not straining. It's holding back. But there's one more reveal, and it explains why this helicopter is unmatched on Earth. The CH-53K's real strength isn't just lift power. It's the consistency of that lift in places where no other helicopter can operate. High mountains, desert heat, rough seas, heavy storms. This is why the US Marines call it a strategic asset, not just an aircraft. So the next time you watch the CH-53K King Stallion blasting dust into the sky, remember this: you're not watching a helicopter struggling to rise. You're watching a machine so powerful, it must restrain itself. A machine built not for comfort, but for the impossible. A machine engineered to dominate the skies, no matter the environment. If you love deep military aviation breakdowns like this, hit subscribe, tap the bell, and join us for more real power reveals behind the world's most advanced aircraft. And tell me in the comments, which helicopter should we decode next?